Alrighty, everybody, welcome to chemical bonding. Woohoo! The first part of the year was all about elements, and now we're going to talk about compounds. And we're going to start off by breaking chapter 6 into two parts. Part A, covalent bonding. But before we do anything else, okay, we have to start learning the most important things out there are ions. Okay, our ions are those charged atoms. This is stuff that you probably remember from the previous videos. We can have cations and anions. And cations are going to be positively charged and anions are negatively charged. Okay, the cations have less electrons than the neutral atom and the anions have more. Okay, so these are going to be negatively charged, these are positively charged. Remember, we don't change our number of protons, so it's all about the electrons. All right, so you should have received or find a link to the common ion sheet. So if we click on that, you'll see it is this awesome gold colored sheet. And you'll see that there are 6 different sets, and it tells you exactly how to memorize each one of them. I highly suggest flashcards or anything like that. Um, Also note that if you see a 1 plus or just a plus, they are the same thing, as well as a minus or a 1 minus. Those are the same thing. And be careful of subscripts and superscripts over here. But we definitely will go over how to learn all of these things. All right, sets 1, 2, and 3 are the cations. Sets 4, 5, and 6 are the anions. So this is the top half and this is the bottom half. So that can help you out a little bit right there. Next thing. Okay, set 1 are going to be all of your cations with a 1 plus charge. And since they are cations, you'll see that they are named as the element name and the word ion. So it says hydrogen ion. If you just write hydrogen down, I'm thinking that you mean just H, whereas hydrogen ion means the H plus. Okay, everything in group 1 on the periodic table is a 1 plus. The only thing else inside this part or inside this section is going to be silver. All right, and if you find silver, it's in group 11 on your periodic table. 11 is made up of 1s. It will always be a 1 plus. Okay. Transition metals require a Roman numeral, okay, in order to show what their charges are, because they can be charged multiple things. So if it's a 1 plus, it's going to have a 1. If it's a 2 plus, it's going to have a Roman numeral 2, 3, 4, etc., etc. So you'll see in this section we have copper 1 ion and we have gold 1 ion. You have to put the 1 in there. All right, and then you'll see that there is one very special thing here that you've never seen before. This is something called a polyatomic ion. Poly meaning many, atom meaning elements, so many elements that make up this ions. It's like this little wannabe gang of elements that pretends it's an element, but it's not. Okay, so the one that you need to know about this is ammonium. It's not ammonia. Okay, so be very careful with that. If you've heard of ammonia before, that is the non-charged compound NH3. Ammonium is NH4 1 plus. Remember, this means 1 plus. Okay, you have to be very careful with your spelling with chemistry. All right, next we have set 2. All the set 2 ions are a 2 plus charge. That means everybody in group 2 on the periodic table. Everybody else is a transition metal with those Roman numerals. The other exception to the transition metal rule is going to be zinc. Zinc is only a 2 plus. He's in column 12 and he is on a diagonal to silver. All right, so you're going to see that silver and zinc are next to one another. He's in group 11, he's in group 12, 12, 2, 11, 1, etc., etc. You know where we're going with that. And the other last thing to be mindful for these ions is mercury 2 ion and mercury 1 ion. Mercury 2 is Hg 2 plus, but mercury 1 ion is Hg2 2 plus charge. So if you were to divide out the charge by the numbers of mercury, each mercury is a 1 plus, which is why it is called a mercury 1 ion. Okay, the 1 has 2 of them adding up to a 2 plus, whereas mercury 2 is just the 2 plus. So be careful with those in there as well. All right, set 3 ions are all of the 3 plus and 4 plus, and almost all of them have Roman numerals. And they will say things like manganese 3 ion or manganese 4 ion. 3 is 3. IVs go in your forearm. Get it? Forearm. An IV intro. All right. Anyway, the only exception to that in this ion sheet is going to be aluminum. Aluminum is always and only a 3 plus and is in group 13. So they are part of the diagonal on the periodic table. You know, your best friend. You have Ag plus, you have Zn2 plus, and you have Al3 plus. And you'll see he's in column 11, this one's in column 12, and this one's in column 13. All right, plus 2, 3 plus in columns 11, 12, 13. There are definite patterns to the periodic table as you learned from the previous chapter. Okay, set 4 monatomic anions. These are all going to be negatively charged ions made up of just one element. And to show that it's different, it's going to end in the name as IDE. Okay, and its position on the periodic table tells you what its charge will be. So if you're in group 17, a halogen, you will always be a 1 minus. If you're in group 16, you'll always be a 2 minus. Group 15 will always be a 3 minus. Group 14 will always be a 4 minus. You always want to be a noble gas. All right, so this is where you will see things like where you will see chloride, oxide, nitride, carbide. All right, and this is Cl minus, O2 minus, N3 minus, C4 minus. Yes, you can always use a periodic table. All right, there is one notable exception to this. Hydrogen can go both ways. It depends on the name and what it does. All right, hydrogen is a 1 minus or hydrogen is a 1 plus. If it's hydride, it's going to be a minus anion. If it's hydrogen ion, it's going to be H plus. If you just write hydrogen, you guessed it, it's just the regular old neutral hydrogen. All right, so that brings us to set 5 and set 6, which are the toughest ones because these you don't directly use the periodic table for. These will take work. I am not saying that it won't. Okay, but set 5 are all the polyatomic anions with a 1 minus charge, and set 6 are all going to be the ones with a 2 minus or 3 minus charge. Okay, polyatomic ions have special names. All right, they usually end in an ate or an ite, but some cases there are some ides. And sometimes you have to come up with funny things to remember them, like cyanide, Cn minus. Okay, this is a deadly poison. Cyanide is made up of carbon and nitrogen, and hopefully, don't take any. Okay, hydroxide is made up of hydrogen and oxygen, but you're not Santa. You don't say ho, ho, ho. You say oh instead. Way better. Okay. If you have a polyatomic ion ending in an 8 and an ite, the one with less oxygens will be lighter. The one that has more oxygens will have the 8. So nitrogen has an ite and an 8 version. Okay, so the ite version has one less oxygen than the 8 version, which is NO3. So this is NO2 with a 1 minus charge. This is NO3 with a 1 minus charge. And if you think about it, 8 sounds like 8, and number 8 is great. That's oxygen. And it's all about the polyatomic ions that have oxygen. So you're going to have to do some work. You're going to have to come up with ways to remember it, writing them out 10 times each, something like that. Okay? There are 4 polyatomic ions of chlorine. Oops, let's go back here. All right, there are 4, like I said, polyatomic ions of chlorine right here. There is hypochlorite, chlorite, chlorate, and perchlorate. So ClO has 1 O. Hypo means very low. Okay, ClO2 1 minus is lighter than chlorate. ClO3 1 minus, he ate 1 more oxygen. And perchlorate has 4. And this kind of sounds like the 90s songs Percolator. It's time for the percolator. And it's time for the percolator in here. So, like I said, there's some things that you're going to have to come up with on your own. Some things you can borrow from me. You'll also see in set 5, sometimes it takes a couple of minutes, but you have to learn set 6 at the same time. So some of these polyatomic ions in this group have a hydrogen bonded to another polyatomic ion from set 6. Like in this group, we have HSO3 1 minus, hydrogen sulfite, where sulfite is in set 4. And if sulfite is SO3 2 minus, hydrogen sulfite is H plus and SO3 2 minus together. So that's HSO3 1 minus total. The plus and the 2 minus make for a 1 minus. Sometimes they're called bisulfite. Bicarbonate does the same thing. There's lots of elements and compounds that do these. All right, and then lastly, we have set 6, the polyatomic ions. These are also going to follow the same ite-8 rule. Okay, the ones with more oxygens will be the 8s, the ones with less will be the ites. So you see sulfite is SO3 2 minus, sulfate is SO4 2 minus. But the 3 and the 2 with the ites and the 8s, sulfite, sulfate, 3 and 4. Okay, so to review, use the periodic table for your ions. For the polyatomic ions, you know what? That's the next video that you'll see. So if you are in group 1, you are a 1 plus. Okay, everybody here is a 1 plus. If you're in group 2, you are a 2 plus. Everybody in the middle over here, including everybody on this side of the line, is going to use Roman numerals. Okay, the only exceptions are aluminum, zinc, and silver, that diagonal I was telling you about. 1 plus, 2 plus, 3 plus, always. Okay, your noble gases make no ions. They already have a full electron configuration. Everybody in column 17, your halogens are a 1 minus. Everybody in column 16 are a 2 minus, 3 minus, 4 minus. Okay, these guys all end in IDE for the names, and these guys have whatever the element name is, an ion. And then stay tuned for the next video for Nick the Crafty Camel in order to figure out your polyatomic ions. All right, good luck. Learn your ions, use flashcards, use Quizlets. Super, super important. You're going to use them every day now until the final.